When you're first getting started with deploying code online, it may be tempting to use a single EC2 instance. You pick the smallest size that makes sense, you deploy code, and you run it there. However, as soon as traffic increases beyond the capacity of that instance, so let's say it needs more CPU or memory than is available on that instance, you need to now shut it down, bringing down the service, and then increase either the compute capacity, memory capacity, maybe it needs more I/O, and bring it back up. During that window, your service is down. Or, alternatively, you increase it, you keep increasing, you make a larger and larger EC2 instance, but now it's evening and no one's using your service. So now you're paying for unnecessary compute capacity on that single instance. In this way, it makes more sense to pick a smaller instance that will handle a reasonable amount of load at the kind of the low side of things, and then deploy your code out and increase the capacity horizontally by deploying more of these small instances in greater quantities during peak time, but then scaling back down during low traffic periods of time. So when you're creating your auto scaling group, you define a couple of things. So the AMI is on there, that's the base machine image on there. You can tie it directly into a code deploy process, or you could have code deploy configure that. You define, so you have minimum group size, maximum group size, and then you can set some rules in there. And some of the rules would be like the when CPU exceeds 50%, add another instance. And so as the group continues to receive traffic, the CloudWatch metrics are taking a look on a continuous basis. What's CPU looking like? And within about a couple of minutes, if your CPU increases above, let's say, a 50% threshold, more and more instances are scaled in up until you hit the maximum group size policy. Then, as traffic decreases, let's say now we hit the evening time period, as traffic decreases, your CPU is going to drop down on average to say below 25%. And in that range, we're going to say pull out an instance. And in that way, the auto scaling groups become dynamically scalable to account for the type of traffic or for the quantity of traffic that you have coming in without overpaying for or kind of being oversubscribed on compute capacity. So that's why we use auto scaling groups. And the other benefit too is going back to that initial point, which is when you have that maintenance problem of the EC2 side of things. If one of your instances in an auto scaling group needs to be brought down for maintenance or otherwise, ASG automatically brings in another instance in place of that. And so if you have the appropriate minimum group size, if one instance is brought down, traffic just flaps over to the next instance in there, or the amount of time is reduced when something would be down and another one is brought in quickly, typically much faster than any human coming in to intervene and fiddle with the system and do some debugging can handle. So that's the whole reason why we target auto scaling groups rather than specific EC2 instances and trying to do the guesswork on, oh, what's the right size for this one instance. It makes more sense to scale in and scale out groups of certain sized instances, and we can play with that as a group rather than just a single unicorn instance. And so we want to have a cattle of a herd, if you will, of servers that we work with. So that's why we use ASGs over just individual EC2 instances. In the next video, I'll go through the process of how to configure your ASG.